Hey guys, how's it going? Yeah, just long day today and lost my voice and everything. Um, so, I know I got a lot of questions sent through, and I'll be honest, like I just couldn't put all the questions together and kind of answer them because that's how many questions that we actually got through. So, I guess what I wanted to do is I've got a couple of questions to ask you guys. Whether do we want to just go straight up into some merit and excellence questions, or do we just want to go through a couple of quick achieved questions in algebra and calculus so that people are feeling confident? Jeez, can't keep up with the comments. Right, I think that says merit and excellence, even though I put slow mode on. That's fine. Let's actually do some of these questions then. What is it? What is it? What is it? Okay, let's do a nice calculus question here. This one seems to pop up every now and then, a question like this. So we'll actually go through this question here. So just chuck it up there that it's calculus so that if you guys do see it, then you know what it is. All right, so what we've got in this question is we've actually got a parabola and a tangent at the point x equals to 3, and it passes through the point 0, 4. So if we were to just roughly sketch this, all right, now we don't know what whether p is actually positive or negative. So potentially we could actually have two situations. We've got a quadratic that could be like this, or it could be upside down. All right, the next thing is where x equals to 3. So where x equals to 3. So let's say, geez, this is going to be very interesting. Doesn't matter. Let's say x equals to 3. Again, this could be either way, guys, so it doesn't really matter. But what happens is now the tangent of that is going to go through 0, 4. I guess it's not going to be on this side because, get out of here. That is not going to work out. So what we're going to do is maybe try out this way. So let's say if that's x equals to x is equal to 3 there, then the tangent actually goes through 0, 4. So let's say it looks something like this, all right? So if that's the case, what's the first thing we need to figure out is we actually need to figure out what the gradient function is. So to figure out what the gradient function is, we're going to write down what our original function is, which is px squared plus 4x minus 5. We're going to differentiate it. And so when we differentiate it, we're going to get 2px plus 4. So that is the gradient function. Now, what we also know, and I don't know, I might be actually doing this the long way. There might be a slightly easier way to do this, but I'm also going to find out what is the y value when it's 3. So f of 3 is, I'm going to put it into the equation. So I've got p 3 squared plus 4 times 3 minus 5. I'm going to get 9p plus 12 minus 5, which equals 9p plus 7. So basically the point that I have is 3 and 9p plus 7. That's basically this point right here. So the other thing that we also know is it's a bit kind of like a tricky question here, because if we look at the gradient function, we already know that it's 2px plus 4, but what we know is the gradient itself is 2p. Because if you think about it, this tangent here, the tangent gradient is going to be 2px plus 4. Actually, not 2px plus 4. That is the gradient function. So what can we do? So we got the difference of these 2 points, 0 and 4. So because the gradient is equal to 2px plus 4, what's that going to do? Nuts. This is what happens when you come back from a parent-teacher meeting and you're like, how did you guys get 2x plus 4? Why do you put p equals to 1? Come on, CK, think. What can I know? I know that the gradient is 2px plus 4, so if that's 2p, I'm going to do x2 and y2, x1 and y1, so gradient is equal to y2 minus y1 divided by x2 minus x1. So I've got 9p plus 7, take away 4, divided by 3 minus 0, which actually gives me 9p plus 3 divided by 3. So the gradient equals 3p plus 1. And because the gradient of this line here is 2p, can we actually say that 3p plus 1 equals 2p, and then 3p minus 2p equals negative 1. So p is equal to negative 1. How'd y'all get 6p? Maybe an hour before I pretty much crash. Well, see, the way I saw it was the gradient function itself, it's a straight line, and I'm looking at the straight line's gradient. Like, so when I look at this 2px plus 4, right? So that is actually the equation of the red line, all right? So for the red line, the gradient is 2p. And so between those 2 points, the gradient has to equal to 2p. So like the red line is the gradient function itself. So that's what this line is, 2px plus 4. Because if you think about it, when you put x is equal to 0, you're going to get y is equal to 4. That's that point right there. Can't you solve for p using the original equation? I'm not sure how you would solve for p from the original equation, Raksha. Darren, no, the red line that I've drawn here, that equation is 2px plus 4. So that actually has, the equation of the line is 2px plus 4. So if you look at the red line's gradient, because what I'm doing here is I'm looking at the point, so notice how that's 3 and something else, and this is 0, 4. Now the equation of this line is 2px plus 4. So plus 4 is being the y-intercept, which means the gradient of this line is equal to 2p. So when we do x2 and y2, x1 and y1, what we're going to have to do is y2 minus y1 divided by x2 minus x1 equals to 2p, which is the gradient. Yeah, actually, this is from one of the calculus questions that was actually sent to me, which tends to be like I mean, this would be an excellence question, so for calculus anyway. Hayden, there's probably another way of doing this, but right now my head is only thinking about this particular way. Josh, when you are working with the gradient, it's always good to keep that y2 minus y1 divided by x2 minus x1 as a backup. That's basically just rise over run. It's just another formula for gradient. That's all it is. Just give me 1 second, folks. All right, so next one we're going into. So we are going into algebra, I believe. Is that correct? Where are we up to? Sorry guys, just give me 1 second, just sorting out a couple of things. Just to make things easy for me. All right, so algebra. Here we go, algebra. Oh, rates of change. Okay, really quickly, rates of change, all right? Because I know some people have actually asked me this question. And like, all you guys got to do for rates of change, right? Like, let's say you got like a rectangle and they might say like the side is increasing. Let's say this is base and then your length or your height, whatever it is. So you write it up as area is base times height. So usually if it's like something like 3x, then the area is equal to x times 3x, which equals to 3x squared. So that's what area is. So if you want to find out what area changing with respect to x is, so you might actually say that dA dx is equal to 6x in this case. All right. So all it's saying is that the area changing with respect to x is just 6x. Real quickly, just going through rate of change off the top of the top of my head. Another algebra question. No, that's an excellence question. All right, so here is a good discriminant questions right now. So with a discriminant question, what we've got is desktop save. This one here. So first they're actually asking you guys to complete the square in this, which is quite annoying already because you've got 12k in there. And then they're asking you to find the possible set of values for x given it has no real roots. Wow, that is a kind of a handful right there. But let's try and do this anyway. So how do we do this? Let me actually do this question without the k, just to show you guys how you'd actually complete the square if you do get a question like this. All right. So if, let's say in this case, we don't actually have the k and just have like 12 by itself. So to complete the square, what you have to do is you actually take the 12x, you got to divide it by 2 and square it. So in this case, what we're going to do is we're going to rewrite this as x squared. Well, actually not x squared. We're going to write it as x plus 6, and we're going to square it. Now, the problem with this is when you do 6 squared, you're going to have 36 that you're actually adding onto it. So what we need to do is we need to subtract 36 away from it. Because when you actually expand this, what you're going to get is x squared plus 12x plus 36 minus 36 plus 9, and eventually you're going to get x squared plus 12x plus 9. All right, so that's what we started with. So if we want to complete the square, what you need to do is you need to divide the coefficient of x by 2 and square it as well. So what we got here is eventually we're going to get is x plus 6 squared minus 36 plus 9. So this could be written as x plus 6 squared minus 27. So that's pretty much the idea behind completing the square. Euler, perfect square is basically just the concept of having the same roots. So if you have two equal roots, that's the same thing as saying perfect square. All right. So I know last year they did that where they put their question and they go where they said like, oh, here's a, find this question so that it has perfect square. Okay, so I showed you guys how to do it with just the letter, just without the k. So what happens with k? With k, it's a little bit not different, but still kind of following the same procedures. So the issue right now is that we've actually got 12k. All right, so when we take 12k and we divide it by 2, we are going to get 6. In fact, you would actually get 6. No, not like this. 12k divided by 2 is you end up with 6k. All right, and when you squared 6k, you are going to get 36k squared. So what we're going to do is when we write this in P and Q, we're going to write this as x plus 6k squared minus 36k squared plus 9k. So basically the first part of the thing that I showed you guys was just completing the square and then now doing it with k. Muddy, you always have to divide by 2 when you're completing the square because like that's the whole point of completing the square is that you want to get the same 2 brackets. So as you can see, I got x plus 6 squared, and then here I got x plus 6k squared. So you want the 2 same brackets. The x plus 6, I got it from dividing the 12. So pretty much, yeah. So that's what it was. All right. So what we've actually calculated here is we have done the first part, which is x plus p plus q. So we can literally say that p is equal to 6k and q equals minus 36k squared plus 9k. Now, I don't know where I actually picked up this question from, but they're saying find the possible values for x given f of x has got no real roots. So what we're going to do next is look at the next part of the question, which is x squared plus 12kx plus 9k. It actually said that find values for x given no real roots. I get a feeling that they might have done maybe a typo with this question. And the reason I say this is because when you actually work out b squared minus 4ac, you're actually going to have no x value. So I think there might have been a typo with this question, and that should have been a k. Because what we've got here is b squared minus 4ac has to be less than 0. So if that's the case, our b value ends up being 12k, our a value is 1, and our c value is 9k. Why did I add 9k? Wasn't it already there? Now, it was already there in the question, man, the 9k. Unless I made a no, I just copied it wrong there, sorry. Anyway, let's go back to this one here. So this is the issue that we have right now. So what we have is 12k squared minus 4 times 1 times c, which is 9k, and we're trying to prove for what values of k is less than 0. So we got 144k squared minus 36k is less than 0. No. I'm actually going back to the original equation, guys. Like the completing the square was part of the question because it actually said write it in p plus q. So I've done that. Now I'm going to the second part of the question where it actually says, so look at this. There's actually two parts to this question. The first part of the question is from here to here. And then the second part of the question is actually from, notice how it says and. So we're actually going, I'm doing the second part of the question, which is the orange part. So going back to this, I've got 144k squared minus 36k is less than 0. Now what I could do is I could actually take k as a common factor. And what I'm left with is 144k minus 36 is less than 0. Now this part is really, really important, right? But the good thing is we can actually just draw this real quickly, because what we have in this situation is we've got a positive parabola. So that's the first thing. We've got a positive parabola like this because of the k squared. And what we also have is we've got our first value where k is equal to 0. We're just going to put it equal to 0. All right. Anytime you get this, then what you can always do is like put it equal to 0 and just kind of solve it, because that's going to give our two endpoints that we need to work with. So the second one is 144k minus 36 equals to 0. And when we rearrange this, we're going to get 144k equals to 36. And k equals 36 divided by 144. So k is equal to 0.25. Now, these are our 2 points. Our first point is 0, and our second point is 0.25. And we're actually looking for less than 0. And because it's less than 0, the zone we're looking at is that pink zone right there. So the answer we're going to be getting is between 0 and 0.25. And no problems, Cam. Just doing it for whatever it is that I'm doing. I don't know why I'm doing this, but just do it. Yeah, so Daniel, this would be an excellence question for sure. We are looking for less than 0 because there are no real roots. Yes, that's correct, Joseph. You're on the right whack. Right. Wow, I can't even say words right. How did k become 0? So this step here, what I've done is I've just converted it to looking like this, because I want to figure out when it's actually less than 0. I actually put equals to 0 and solve for the two of them. All right, and if I solve for two of them, then I'm going to get the 2k values. Yeah, okay, thank you very much, but I don't need it right now. Yeah, so no real roots is basically, I mean, like, look, you're going to get a discrimination question, discrimination. Oh, man, I'm losing my words today. Discriminant question, all right? So if you forget it, just remember this diagram. 2, 1, right there, and none. So you're always working with b squared minus 4ac. This is two solutions, one solution, none. Sometimes they write it as no real roots. Perfect square comes under here. What else did you need to know? This is greater than 0, equals to 0, less than 0. So this part is super important. If you can remember this, then it usually ends up, you're going to get one question at least on algebra that's going to have discriminant in it. Yep, so they also call this equal roots sometimes. No, you can actually use them all, but it's just like it's just the equation has different meanings. So what I mean by is you would have, in this case, you're going to have equals to 0. In this case, it's going to be greater than 0, and in this case, it's going to be less than 0. Yeah, kind of doing both, guys. I'm just doing algebra and calculus because, yes, Sabertooth, I believe it's in my link in the description. There's a notebook. You can click on that, and if you go there, you should be able to access it under level 2 maths and level 2 help desk. Log questions. Okay, quick log question tips that I'll just do very quickly with some log questions. Just give me 1 second. I need some water. All right, so some log questions like, and I'm going to give you guys some really quick achieved questions just for those people that are kind of hanging around. Just some quick tips, all right? So when you get a question like this, you might get something like this, 3ab squared over 2a squared to the power of -4. I'm just going to run down real quickly, right? So when you're dealing with negative powers, real quick thing, switch it. So you can actually rewrite this as 2a squared over 3ab squared to the power of +4. All right. Another good trick is putting ones for the powers that you don't have, so that you actually multiply all those powers together, so that you can actually get the correct answer in this case. So what's going to happen is you're going to get 2 to the power of 4, a to the power of 8, 3 to the power of 4, a to the power of 4, and b to the power of 8. And always remember, you got to simplify right to the end. So don't just leave these a values, otherwise you end up not getting the full grade. That's one thing. Second little tip: when you get a question like this, and this is, I've seen it pop up every now and then, so where they put like a to the power of 7 equals, well, not even a to the power of 7. Let's actually do something like this. Oh, we're going to try that again. So this is a really handy hint for getting rid of powers, right? So if you have x to the power of 2/3, and that equals 10, instead of taking logs and trying to work this out with using logs, which can take a bit of time, what you can actually do is just rewrite this as x equals 10 to the power of 3 over 2. That really helps out. Yep, I got that, Samrat. I will get onto that one as well. All right, so that's a really quick little tip there. And of course, if you're using logs for this, then what happens is it ends up, logs is only useful when you're trying to find the power. So if the same question looks like this, so say for example 7x equals 10, then taking logs would actually help you out. So you actually go log of 7x equals log of 10, and then bring the power to the front so that this becomes, what does this become? X log 7 equals log 10. So then x just becomes log 10 over log 7. Now remember guys, if you do get in trouble, like you kind of forget how to do this, you always have your graphics calculator and just go and use the equation function in your calculator, and there's a button called solver. So just click on that and just put this equation in, which is 7 to the power of x, and you put it equals to 10, and just make sure you click on solve. So in this case it's 1.183, but if I go back to my normal menu and I go log 10 divided by log 7, I'm going to get the same answer as 1.183. Also remember this, it doesn't matter whether you use log or ln, you will still get the same answer. So if I do ln divided by ln of 7, I'm still going to get the same answer. But what you can't do is you can't mix up log and ln. All right, so you can't, like, just make sure you use one of the same one, and you should be all good to go with that. All right, so I got a real quick question. Okay, off the top of my head, Ayush, it's really hard, but what I'm going to do is I'm going to do a quick merit question with calculus. Yes, Jessica, real quickly, just click on menu, go into equation, and then click on solver, which is F3, and I'm just going to clear this whole equation out, and then I'll do the whole thing again. So just click on 7 to the power of x. Make sure you use the x underneath the red alpha, and then put shift full stop decimal point, which is the equals button right there, and then put it equals to 10 and solve, and click on solve, and you should be good to go. Yeah, now probability is I'm having trouble keeping up with these topics. If I start probability, I need to quit my job, because I'd have to say this is the first year that I've not been able to get to every question that you guys have actually sent me. It's just been way too hard to keep up. All right, so really quickly, I wanted to do this question here, like this question that pops up with the area. Sometimes they ask, you know, what's happening here. So if you get a question like this, so let's say this is y is equal to x minus 5 squared. All right, and then they say something like there's going to be a rectangle inside here, and they want to find out what's the maximum area. All right, so let's say this is one of the questions, right? What is the maximum area possible for this rectangle that we actually end up getting? So the way we're going to have to do it is that the rectangle has area is base times height, right? So we've got area is equal to base multiplied by height. Now the base part is going to be this part right here, and then the height of the rectangle is going to be right there. So what's happening is we're going to look at this particular point here, and if you look at it that way, it is x and whatever the y value on that parabola is. So in other words, we can actually say that this point is x and x minus 5 squared, because that is the value of y on the parabola. So because of that, what we can then say, the base is going to be x, and the height of the rectangle is going to be x minus 5 squared. So what you really have is area equals x multiplied by x minus 5 squared. So once that's the case, we're pretty much good to go after that, because all you have to do is expand this cubic, and once you expand the cubic, you differentiate it, put it equal to 0, and you can actually solve. So this is like a standard, I don't know if this is a merit question at level 2 or an excellence one, I can't remember, but I definitely know it's not an achieved question. I'm thinking it's probably merit, but could be excellence. But anyway, look, let's just do this. So we've got area equals x. I'm going to expand this quadratic, which is x squared minus 10x plus 25, and then area equals x cubed minus 10x squared plus 25x. So at this point, I'm going to differentiate this, and I'm getting 3x squared minus 20x plus 25. And of course, the maximum area happens when a dash is equal to 0. So I'm going to put 0 equals 3x squared minus 20x plus 25. Now I'm not going to waste my time, Marcel. I'm just about to answer that question to you. I'm not going to waste my time trying to do this with a quadratic formula, or I'm going to try and factorize it. You know what? I have a graphics calculator, so use it. And this is why one of the main reasons we say is like, there's a lot of time you guys can actually end up saving if you use the graphics calculator. So I'm going to go into polynomial, which is f2, degree 2, and I'm going to punch in those numbers. I've got 3 minus 20 and 25. So when I do this, as you guys can see, I'm actually getting two answers here. All right, when x equals to 5 and when x equals to 1.6666. But here is the problem. The problem is this: when x equals to 5, I'm actually going to get no rectangle, because if x equals to 5, then the base of this rectangle is going to go all the way like that. So I'm not actually going to create a rectangle. So I have to actually ignore x. In this case, I have to say x can't be 5, as there's no rectangle. Therefore, x is equal to 1.66. Carbon, no. You can actually do the working for the quadratic, unless it's a value, like, how do I put it? If you have a quadratic equation, you don't need to show any working. You can just put it straight away in the calculator and just get it done. Jordan, if you're using the solver function for logs, one of the tricks is to make sure you show the log working. Otherwise, they don't tend to give you full marks, particularly for the excellence questions. It's really a good idea to show the at least a couple of steps just to know that you're on the right track. All right, I'm going to pick up this question here, which you just put up, just because it is. So you got y equals ax squared plus bx plus c has a tangent to the curve at -1, 8. Another tangent to the 4 and 13. Talk about a horrible question for starters. Has a tangent. Kazali, I'm just wondering, have you got all the information there? Because I'm just looking at it. Ax squared, it's quadratic. I'm just looking at it, Kazali. I'm just thinking, like, is there something missing in that question? Either that or my head is not working at the moment. Sure, Ella. Just going back to this question, can you explain finding where the rectangle and parabola intercept again? So, like, basically the point, this point right here that I'm going to color in pink, that point is actually moving along the parabola. So it's a rectangle formed by, so basically, like, you could get another rectangle that looks like this. All right, so notice how that point is always going to be xy. And so it doesn't matter where I go on the point, I'm always going to end up with that x and y coordinate. And because of that, I just use the equation of the y to actually try and put it through. Tom, that's actually a really good question, man. I'm gonna come back to this one. My head is not working right now, but where is it, Tom? Where was your question? That was a really good question because that's a good one to have in your 2x cubed plus. All right, guys. So this question here, which comes in calculus, it's kind of like a double barrel question because it does help you with understanding how those limits work with less than 0 and greater than 0 and so on. All right. So what we're going to do is we're just going to differentiate this. So when we differentiate this, we're going to get f dash of x equals 3 and 3 cancels out. So you're going to get 2x squared plus 9x minus 5. Now, it is actually saying when is this graph actually increasing? This would be an excellence question, yeah, for sure. So in this case, we're going to go 2x squared plus 9x minus 5 greater than 0 because it's actually increasing. Now, again, at this point, I am not going to waste my time trying to find those 2 points because look at this graph. This is a parabola because it's a positive parabola and it goes like this. And what I know is that it's going to cut across 2 points. But to find those points, I'm just going to go straight into my calculator and I'm going to chuck in those values. So I've got 2, 9, and I've got -5. So as you guys can see, those are my 2 values, 0.5 and -5. So that's -5, that's 0.5. Now this ends up being an excellence question, and to be honest, it's one of the more easier excellence questions because all you got to do is just figure out the right zones. But you can't just write x equals -5 and 0.5. No, you don't need to show the working. You can just get the point straight away in calculus. So here, we're looking for greater than 0. So that's going to be our zone. And that's going to be our zone. So we're going to write down that x has to be less than -5 or 0.5. X has to be greater than 0.5. All right, Kazali, I'll come back and have a look at that question again. I'm sure I'm just missing something in that. Cool. So that ends up being an excellence question there. Can you please do this question? Graph of the phone. All right. Let me see if I can pick this one. All right, guys, look, I know kinematics just keeps coming back up. Just to give you guys a quick summary of kinematics. So remember that you've got SVA, and basically to go this way, when you go from displacement to velocity to acceleration, you're doing differentiation. And then when you go backwards, you are doing integration. But here is the most important thing that people forget. When you're doing integration, always remember you got to put the plus C. All right? It doesn't matter whether you're going from acceleration to velocity or velocity to displacement. You have got to put you've got to actually put down plus C. All right. So what I mean by this is sometimes they give you questions like this. Acceleration is equal to 4. That means your velocity is going to be 4t, and people just stop at that. Right? Make sure you put 4t plus c. And also keep in mind of these words. Initial velocity is, I don't know, 4 meters per second. That basically means when t equals to 0, v equals to 4. All right, and sometimes they'll say like they might actually not give you the starting point. Like if they might say like, oh, from this point, how long does it take for the car to stop? So at that time, you can actually assume that when t equals to 0, s equals to 0. This is particularly useful for those questions where you try to. This is particularly useful when you're trying to solve questions where they ask you like how, like after this much time, or how long does it take to come to a stop and stuff like that. All right. Generally, nay is that t does stand for seconds unless they tell you guys so. Cool. Very quickly, that question is actually quite interesting, Bangcha. Give me a second. I'm just going to write it down. Y equals x minus a. How would you do something like this? Well, you just have to prove that the discriminant is positive in that case. So, like, remember that like it says that it's crossing two points, right? So if it's crossing at 2 points, then you have to say that discriminant is positive. So all you got to do is expand the brackets. You're going to get x squared minus bx minus ax plus ab minus c, for example, right? So here you're going to get x squared minus b minus a x. I'm just going to put a plus there, plus ab minus c. And then here, because that is your b value and that's your c value, I should have put it in a different color. So what you've got, Bangcha, is like this: b squared minus 4ac has to be positive. So negative b minus a squared minus 4 times 1 times ab minus c. So eventually what you'll actually realize that this number, everything is positive, and because everything is positive, you can actually say it's greater than 0, therefore it will have 2 distinct roots. That's how you would do this question. Depends on your school, Bharat. I don't know, man. Like some people have like different requirements. Where did that question go? Damn it. It was a good log question. Jeez, that's a horrible log question. Ah, my goodness. I don't even know why. Where did you get that question from, that log question, Yute? Long story short, I'll show you quickly how it actually looks like. So this is what it looks like, right? I hope this is what it looks like. So basically this question here, remember your log rules. So if you have log of 2, 8 equals to 3, then you would write this as 2 cubed equals to 8. So in this case, what you're going to write is 2x plus 1 cubed equals to 2x cubed plus 13x squared plus 8x plus 1. So even though it's a log question, it's just a really annoying cubic question that you got to do. So what ends up happening is you actually expand that cubic out here. So you got 2x plus 1 times 2x plus 1 times 2x plus 1. You expand it and then put it equal to 2x cubed plus 13x squared plus 8x plus 1. And I'm guessing you're going to end up with like ending up with a cubic which you should be able to factorize. Yeah, just got to expand it, that's all. There we go. That's that. Got it. Wait. Where did the question go? So what did I miss? So y equals ax squared plus b cuts at one tangent to the curve negative 1, 8 and another to 4, 13, tangent at negative, cuts y at 0, negative 1. Okay, so it has a gradient. I'm guessing this part, like, look, I could be completely wrong and it's just like late into the day, but because it says it cuts the y-axis at 0, negative 1, we can straight away see that c equals to negative 1. The next thing is when we differentiate, and I guess this is why I'm asking, have I got the full question there? Or the tangent at negative 1, 8 cuts the... Yeah, Kazali, I think I'm going to need a bit more time to look at that question because I think I'm doing something wrong. Where did you get that question from, Kazali? I might have some notes, my old questions that I can actually have a look at real quickly. Jessica, I quickly did go through kinematics, like, you know, that it's really just remembering that you got to go through PA2E. All right, give me 1 second. Let me just have a look if I have that or not. D&D. Differentiation complex. Damn it, where did that question go? 2EPEA1. Nope, don't have that paper. I have an older book, which sucks. Hey, Ghazali, can you just maybe screenshot the answer for me or the question and just send it to my email, please? I know you've been asking that question. Yeah, that's what I'm thinking, Dane, but like I'm just kind of going back to that question again and again, and I just need to read through it properly. Optimization, real quickly. So with optimization, what's really important is this. You guys kind of have done optimization already, where you did last year with tables, equations, and graphs, all right? Really simple rule for optimization is working through what's been given to you guys, and then the rule is this: you got to write an equation with the same variables. So what I mean by that is, like, if you start off with, like, say, a rectangle, right? So when you start with a rectangle, you've actually got base and height. So that means when you actually go area is equal to base times height, you've actually got two different variables, because you've got the variable b and you've got the variable h. What's important is, for optimization, you want to make sure that all the variables on the right hand side are the same letters. All right, so say for example in this particular case, they say like perimeter of this rectangle is 350 meters. Then your first step is to actually get rid of either the b or the h. So in this case, I'm going to write down as 2b plus 2h equals 350. And so if I say I want to get rid of h, then I'm going to write down 2h equals 350 minus 2b, and then h is equal to 350 minus 2b over 2. So what we've essentially done is we've actually gotten rid of the h and replaced it with this thing right here. All right, so with optimization, it's really important that you guys don't have two different variables. So make sure you have only one variable, and the clues will be given to you guys, so you always will have like what you could substitute it as and so on. Kazali, okay, here we go. Let's pick up this question. Hey Kazali, can you just screenshot the answer as well, please? Because I just don't want to waste people's time by me kind of messing around with it. All right, next question. Next question. I think we should really be wrapping it up, guys, because it is getting pretty late. But the one question I'll really quickly do is this one, which is an algebra one. What is it? Where is it? Where is it? I saw that log question there. I'm going to answer your question, Kazali. Can you just flick me that last? Yeah, just flick me that answer, because I just don't want to waste time. Because I probably need some time to figure it out. But if I have the answer, I can actually get it done in like no time, and actually explain to you guys in a meaningful way. All right. So this question here, we've got. Log of x plus 1 equals log of x plus 7 minus log of x minus 3. So this question, the way you kind of interesting. So the way you kind of do this is, the first step is, because you got that minus, what you can do is you can rewrite this as log of x plus 1 equals log of x plus 7 divided by x minus 3. So that's kind of like the first step that you're going to have to do. The next step is you can get rid of, yep, I'm just waiting for it. The next step is to get rid of the two logs. Where is it? Where is it? Where is it? Right, okay. So to do that, we just, we can just get rid of the two logs straight away, because they're both logs on the same side. So you're going to get with x plus 1 equals x plus 7 over x minus 3. Then cross multiply. So you have x plus 1 times x minus 3 equals x plus 7. And then at this point, just expand the quadratic minus 2x minus 3 equals x plus 7. Rearrange, so you got x squared minus 2x minus x minus 3 minus 7. So you got x squared minus 3x minus 10 equals to 0. Now, what happens here is you got to solve this quadratic, so you're going to get x minus 5, x plus 2 equals to 0. So we can say x equals to 5 or negative 2. But here's the problem. I think whoever sent me this question, they actually said, can you justify which answer is correct and which one is not? Now, in this particular case, x equals to 5 is the correct answer. The reason is, if we put x equals to negative 2, then in this part, it becomes log of negative 2 plus 1, which means you're going to get log of negative 1. And what happens when you actually put in your calculator to try and do log of negative 1? You should get a maths error because it does not exist. So this question that you just sent me, it has to be that x equals to 5. Now, for those of you that are wondering how I got that divide, remember these rules. Log a minus log b equals log a divided by b. That's one of the rules that get given to you. Yep, Maria, you can basically do that because it's kind of like, because you're taking logs on both sides, you can cancel it out when it equals each other. All right, so you can't do it in the top line. So you definitely can't do this in the top line. So you can't just go, I'm just going to rewrite this as x plus 1 equals x plus 7 minus x minus 3. That is incorrect. But when it's actually log of something equals log of something, then we actually then we can kind of get rid of the two logs. Justifying with words, just say logs, like you can say something like you can't actually calculate log of negative number. So log of negative number is not possible or doesn't exist. All right, let's go through that last question there that Kizaeli sent. Basically, it has so the first thing is what they've. This is kind of like just to kind of go back to the question. So the question was, damn it, where did that question go? So the question was, they had this equation and it went through, the tangent was at the curve negative 1, 8, 4, 13, and also something happened at 0, negative 1. For the life of me, I can't see where the question went. Hang on, I can find it. There we go, got it. Oh yeah, so this tangent cuts the y-axis at 0, negative 1. So basically what that means is we substitute f of negative 1 equals to 8 and f of 4 equals to 13 because they are tangents at the curve. So that means whatever the curve is, this curve is a parabola and there's like two tangents. And the first point right there is negative 1, 8 and the second point is 4 and 13. So because of that, we're going to substitute it into the equation. So we're going to get 8 equals a negative 1 squared plus b times negative 1 plus c, which gives us the first answer as a minus b plus c. Then we do the second part of it at 413. So we're going to get 13 equals a 4 squared plus b times 4 plus c. So we're going to get 13 equals 16a plus 4b plus c. Now, this is where this question is actually quite annoying, because what they're doing is, I need to clear some space. Give me 1 second. So what they're basically doing is they're writing these two equations on top of each other to get rid of the c. So if I go 13 equals 16a plus 4b plus c, and then at the bottom I've got 8 equals a minus b plus c. Now I think I already did it, Rebecca, so oh, that one, yeah, no, I didn't actually do the full working for that one. I just kind of let it go with that question. Kind of like, just kind of thought you guys would just kind of carry on with it. But let me just finish up this question, all right? So what we have from here is we can actually subtract this. So when we actually subtract this, 13, we're going to just change all the signs. So we're going to get 13 minus 8, which is 5. 16a minus a is 15a. And 4a minus minus b will become 5b. C minus c is 0. So from this, we can actually say, because 5 is a common factor, 1 equals 3a plus b. And then we can kind of just simplify that b is equal to 1 minus 3a. All right, so the next step is going and finding the what do you call it? The gradient function. So we're going to differentiate this. So when we differentiate this, we're going to get 2ax plus b. So that's what our gradient is. So the next step is we've actually got to work out what the two tangent gradients are. So we're going to substitute f dash of -1. So when we do that, we're going to get 2a times -1 plus b, which is -2a plus b. But here's the thing. We know what b is because we actually said that b is equal to 1 minus 3a. So we're going to substitute it in here. And when we do that, we're going to get -2a plus 1 minus 3a, which gives us 1 minus 5a. And again, we got to repeat the step for +4. I think it was +4, yeah. So we're going to get 2a times 4 plus b. So we've got 8a plus b. And then we're going to get 8a plus 1 minus 3a, which actually gives us 1 plus 5a. All right, so the other thing that we know is when we look at these 2 points right here, I'm looking at these 2 points, because remember that tangent is actually cutting the equation at 0, -1. So that means this tangent will have an equation of mx minus 1. All right, and I know I'm kind of just flying through this at the moment, and I apologize. But yeah, I just want to try and get this question out of the way. So because at 1, -1 and 8, this tangent is actually going through -1 and 8. Oh, but it's going to look like this. So -1 and 8, and it's also going through 0 and -1. So when we think about it, what we have is we've got y equals mx minus 1, and it's going through -1 and 8. So when we substitute it, we're going to get 8 equals m times -1 minus 1. But remember, the gradient at -1, 8, we already calculated it, which is this part right here. So we're just going to substitute that in here. And when we do that, we are going to get 8 equals 1 minus 5a times negative 1 minus 1. And if we rearrange it, we're going to get negative 1 plus 5a. What do we got? Minus 1. So 8 equals 5a minus 2. And we're going to get 5a equals 10. So a is equal to 2. So really, really super, super long question. And yeah, like, I mean, I'm sorry to say this, guys, but this would probably be one of those questions where it's like a double E7, E8 question. Because once we get A, we know that B is equal to 1 minus 3A, which means 1 minus 3 times 2, which gives us negative 5. And I think we've got finally C, because we've got 8 equals A minus B plus C. We can say 2 minus negative 5 plus C. We're going to get 8 is equal to 7 plus C, and C is equal to 1. Now the weird thing is, like, the actual question just keeps carrying on some more. Yeah, this question is like super, super long. And then you got to actually work out the equation of the other tangent, which means you got to go back and do more work. Yeah, definitely say I'm actually going to I'm going to be pretty much on the same page as Mobile Games there. Let me just kind of share his sentiments with that question. Now you shouldn't get yeah, it's still not over, Ayush. Like, that's how annoying this question is. It just keeps going. Guys, honestly, when you get a question like this, I'm going to be honest. Like, if I see a question like that, and, you know, I spent about good almost 10, 15 minutes on this question. Like, you gotta strategize, man. You gotta strategize. You gotta go, okay, is this question going to get me an E7, or is it better to invest in my 2 merit questions so that I can actually get an M6? That's way back here, like the 1 minus 3a. Oh man, no. I'm done for the night, man. Like, I'm been up since God knows how long. No mass questions. Yeah, Anime Gal, I'm pretty much with you on that one. This question just makes me cry too, and I'm not even doing the paper. And in fact, if you look at the amount of work we've done for that one question, this is our entire tutorial today, right? Like, just to give you an idea. Yeah, there you go. That's our entire tutorial, and this was the amount of work we needed to do for the last question. And that's not even finished. So Manami, Yef, like, you just gotta kind of work backwards on this. That's what yeah, that question was just horrible, absolutely horrible. Look, guys, all I'm gonna say this to you is I'm actually done for the night. I'm gonna get some shut eye. But look, tomorrow, good luck for you guys' exams. Don't, as I said to you guys, don't leave anything empty. If you see like a discriminant question, you know, even writing like the discriminant is greater than 0, less than 0, equals 0, usually ends up getting an achieved. Calculus, differentiate when you think you need to differentiate. And if you see a kinematics question, generally it tends to be like a nice integration one. But just make sure that you guys attempt every question. Don't leave anything empty. Apart from that, it's been a crazy, absolutely crazy year, and I just want to wish you guys good luck, and yeah, all the best tomorrow, and let me know how the paper went tomorrow. I'm sure there'll be a few tears, but that's always the case, isn't it? No worries, guys. Big turnout, so appreciate the support, and I will catch you guys next year at Calculus if I see you then. Otherwise, thank you for joining me over the last couple of years. It's been good fun. See you guys.